Welcome to the lecture number 74. These all sums are very important now. Whatever the sums we are going to do henceforth are very important from examination point of view. So I will be spending maximum time in explaining all these three sums. You should be able to understand all minor steps also. So please see here, in this question number 20, it is given CD bisect angle ACD. Then AB is a diameter, O is a center, so AB is a diameter of a circle, and to prove that AD is congruent to BD. Now AD and BD are chords, and I am going to prove it by converse of corresponding chords of congruent arcs. So my aim is to prove arc AD is congruent with arc BD. If somehow I will be able to prove arc AD and arc BD are congruent, then naturally you will be getting that this chord AD is congruent to chord BD. So let's begin now. We will find angle ACB is angle subtend by diameter. Subtend by diameter. This is also activity based question, but I would like to explain this question in detail. So we'll find that angle ACB, this angle is formed by segment AC and BC, and therefore at the point of intersection C. So you will surely find if AB is diameter, then angle ACB is called as angle subtend by diameter. So angle subtend by diameter is always 90. So ACB is equal to 90. ACB is equal to 90. Angle ACD and BCD are 45 each. Reason being that CD is given as angle bisector of ACD. So if whole angle ACD is of 90, so if we bisect it by CD, then actually we will be getting angle ACD and BCD are 45 each. So we'll find that angle ACD is congruent to angle ACD is congruent to angle BCD. That is equal to 45. That is equal to 45. CD bisect angle ACD. CD. CD bisects angle ACD. That is what I have. Then, now please try to understand very important thing. Angle ACD, this angle, as well as angle BCD, this angle as well as this angle, you will find they are inscribed angles. They are inscribed angles. Why they are inscribed angles? Because you will find vertex of ACD lies on the circle, vertex of BCD also lies on the circle. Therefore, they are called as inscribed angles. And measure of inscribed angles is equal to half the intersected arc. So half of the AD is equal to 45. Half of the BD is equal to 45. Conversely, I can say if angle ACD is 45, which is inscribed angle, then measure of arc AD is 90, twice of inscribed angle. It is one and the same. Similarly, I can say if angle BCD is also 45, then you will find that arc BD is 90. So that is what I am going to write now. So you will find here angle ACD is equal to half measure arc. Half measure arc. ACD is equal to half measure arc AD. But angle ACD is 45. That is equal to half measure of AD. If I transfer these two to the left hand side, I get 90 is equal to measure arc AD. If I transfer to the left hand side, it will go for multiplication with 45 degrees. So 45 to the 90. So measure arc AD is equal to 90. Here we must mention reason that inscribed angle. Inscribed angle. Now please find from the side. Similarly, from this side, angle BCD is equal to, if I label it as 1, I can label this as 1. So BCD, position of the vertex of the angle is on the circle again. So angle BCD is also called as inscribed angle, and measure of BCD is equal to half measure of BD. So BCD is equal to half measure of. Reason is same, inscribed angle. Inscribed angle. So angle BCD is equal to half measure of BD. Angle ACD is also equals to half measure of AD. Reason is same. What is the reason? That inscribed angle. Now what is measure of BCD? If you look at the figure, you will surely notice measure of BCD is also 45. So 45 is equal to 45 degree is equal to half measure of B. 45 is equal to half measure of BD, because measure of BCD is 45. We have already proved it. Now you will find 45 to the 45 to the 90. So 90 is equal to measure of BD. Now if you look at the result 1 and 2, or if you compare result 1 and 2, what you can notice very easily, that measure of arc AD is equal to measure of arc BD, because measure of arc BD as well as measure of arc AD is 90 each. So therefore measure of arc AD is equal to measure of arc BD. Measure of each one of them is 90. From 1 and 2. From 1 and 2. From 1 and 2. Okay. So if these arcs are congruent, arc A is equal to arc B. So naturally what result will get now? chord AD is congruent to chord BD. That is what we have. AD is congruent to BD. So chord AD congruent to chord BD. Therefore, chord AD congruent to chord BD. Just to conclude this answer, we can say corresponding chords of congruent arcs. So corresponding chords of congruent arcs. So this is how you will find. Circle is given, diameter is AB, O is, you will surely find center of the circle. Then series bisecting angle, so angle ACB, which is 90, divided into parts as 45, 45 each. Arc AD is twice of 45, 90. Arc BD is also twice of that. Okay, that's all. Now, in textbook it is given in some different way. That is also correct. Now you will find if this arc is 90, then what happens? This angle is also 90. Why angle DOB is 90? Reason is same. What is that reason? Reason is angle DOB is central angle. If an arc BD is 90, angle BOD is also 90. Likewise, from this side also, AOD, if this arc is 90, this angle is also 90. Now what happens here? O is the center. So this is radius, this is also radius. So you will find that DO is perpendicular bisector of A. I repeat again. DO is perpendicular bisector of AB. If DO is perpendicular bisector of AB, any point which is lying on perpendicular bisector of the segment is equidistant from the endpoints of the segment. Last year we all studied this there, which is called as any point lies on perpendicular bisector of the given segment, then its distance from the endpoint of the segment is always same. So, if you will find D is lying on perpendicular bisector of AB, then we get AD is congruent to AB. That is also one of the way to prove. This is also one of the way to prove. So you can follow any way, but if it comes in the type of fill in the blank type of question, then you must have to write as answers expected in the textbook. That's all. Please have a look at this quickly. Question number 21. I am going to solve now. Question number 20. Please see here question number 21. Figure is given. It's very important question here, students. Figure 3.99. Please see that. Figure 3.99. Figure 3.99. In this case, you will find O is the center of the circle. O is the center of the circle. Then you will find there is a chord N is there. Chord N is there. Length of chord N is 25. N is there. So give it chord N is equal to 25. Units are not given. Units are not given. O is the center of the circle. Fine. Then you will find next to that ML is 9. Okay, ML is 9. ML is 9. One more thing is given. OL is 5. OL is equal to 5. Question asked is find out the radius of the circle. Find out. Find a radius of the circle. Find out the radius of the circle. You'll find it is slightly difficult to understand. So M is a chord of length 25 or is the center of a circle. Fine. Now please try to understand. Point A is here. Point L is here. And OL is given as 5. OL is given as 5. OL is given as 5. I'm going to label them as ST. ST. Now, construction is there. Construction is there. Join OT and OS. Join OT and OS. Let radius of the circle, let radius of a circle be x. I'm going to take the radius of the circle of x. So you will find OT is x. OT is x. OT is equal to x. OT is x, correct? OT is the radius, that is x. As well as we will find OS is also x. OS is also x. So you will find OT as well as OS. Each one of them is x. Now it is very important. Please try to understand. LT is equal to LT. That is very important. LT is equal to, please try to understand. LT is equal to LO plus OT. LO plus OT. And that is equal to LO is X plus 1. This is very important reason for me. Okay. So please try to understand. OT is X. OS is also X. But OL is given as 5. So LT is X plus 5. So LOT. Here you can mention L dash O dash. LOTs are collinear ones. Likewise, if I find out LS, please look at LS is equal to LS is equal to OS minus OL. OS minus OL, very important. OS minus OL will give me SL. OS minus L will give us SL. So you will find LS is equal to OS is X and this is 5. So X minus 5. OS we are taking it as X. So you will find LS is equal to X minus 5. So here also we can give reason that S dash L dash O, S dash L dash LS is equal to X minus 5. Now try to understand. This ML is 9. ML is 9. Therefore, NL is equal to NL is equal to NL is equal to NN minus NL. NN minus NL. NN minus NL. So NL is equal to 25 minus 9. 25 minus 9. That is equal to 16. So NL is equal to 16. So these all lengths are very important for us to get the value of x. So please try to understand. SOT are collinear points. Here I am taking a radius as x. That's why I will get LT is equal to x plus 5. Next time we will find this OL is 5. So to get SL, SL is equal to OS minus LO, that is equal to x minus 5. So I got this SL as x minus 5. Total LN is 25. ML is given as 9. So LN is 60. So since you have got now value of ML, you know the value of SL, you know the value of LP, know the value of L. But very important to understand, chord MN and chord ST. These are chords. Chord MN and chord ST are intersecting in the interior of the circle at point L. So chord MN, here I write chord MN and chord ST intersect each other. In the interior of the circle. In the interior of the circle. at point N. That is very important. Try to understand ST and MN are the chords intersecting each other in the interior of the circle at point L. So surely now we can use chord internal division theorem. So by chord internal division theorem, by chord internal division theorem, by chord internal division theorem. Now how to apply chord internal division theorem? Product of the parts of the same chord from the point of intersection is equal to product of the parts of the other chord from point of intersection. Now you will find chord N is divided into two parts, M and L, and point of intersection of ST and MN is L. So I have to take the product of the parts of chord MN as ML into LN, ML into LN. That is equal to ML into LN. That is equal to SL into LT. SL into LT. SL into LT. This is how we apply chord internal division theorem, that SL into LT is equal to ML into L. Now simply substituting the values and to get the value of x, because x is a radius of the circle. Now ML, what's the value of ML? ML is 9. So 9 into LN, see here, LN is 16. So 9 into 16 is equal to SL. SL is how much? X minus 5. So writing x minus 5 into LT, which is x plus 5. I simply substitute the values of MN, LN beside SL as well as LT. Now you find 16 9 is 144. So 144, that is equal to x squared. X squared. X minus 5, x plus 5. That is x squared minus 25. X squared minus 25. X plus 5, x minus 5. A plus b minus b, a squared minus b squared. So 144 plus 25 is equal to, if I transfer 25, so 169 is equal to x squared. 169 is equal to x squared. Taking square root from both sides. Taking square root from both sides. So if you take the square root of 169, you will be getting 13 is equal to x. 13 is equal to x. But what is x? X is the radius of the circle. X is the radius of the circle. Therefore, radius of a circle is Radius of a circle is 30. Because you will surely find units are not given. They are not given as this ml as 9 or something like that. They are not given as. So this is how you will find that radius of a circle is 30. Please have a look at this some carefully. Okay, so very simple that way. What we have to understand, we are going to use chord integral division theorem. That's it. If I take OT as x from point of intersection, this is 5, so I'll be getting LT as x plus 1 in the same way. What is Mn? Is 9. Mn is 9, but total Mn is how much? 25. So we'll find that 25 minus 9, you'll be getting ln as 60. Next one, SL we have to get, but we know OS is also x, because OS is also a radius. So to get value of SL, x minus 5 is equal to SL. So we got the value of SL also. Then I use ML into Ln, that is 16 into 9, that will give me 144 is equal to, this is x minus 5, this whole TL or LT is x plus 5, a plus b a minus b, so x square minus 25. If I transfer it to the left hand side, I'll get 144 plus 25, that is 169, taking square root, so x is equal to 30. So radius of a circle is 30. So this is how we will find we finished this sum. Or so still 5 minutes are there, but you know the duration of the lecture may be less, 30 minutes or something like that, I hope so, or maybe 25. But I would like to give the justice to each and every sum. So I am going to conclude this lecture here. No matter I may be able to finish only 2 sums in one lecture, but very slowly I am explaining all these terms. So thanks a lot, dear students, for attending this lecture, for watching this video carefully. You have to understand the construction properly, as well as the chord integral division. Thanks a lot. God bless you all. Thank you very much.